Very good morning, everyone. So let's start the session for the day. So in today's session, we will be discussing on the security policy and NAT. So before jumping into the topic, I wanted to keep you informed about the changes I have made on the lab. So under system VDOM, I have created a VDOM called policy and NAT, policy NAT, central NAT. So let's see what I have made in this. So in this VDOM, I have made it as a policy-based VDOM, and which by default will enable central NAT. So on the other hand, I have one more VDOM, which is root, which is profile-based, and which is operating in the normal mode. So we will discuss what is the difference between this profile-based and a policy-based, and how the NAT will work in this two scenario. This is what we are going to discuss today. So first, let's start with the root VDOM. Okay, so what is the purpose of policy? So on a firewall, the policy is used to allow any connection by matching certain criteria. It's basically a set of rules which decides whether a connection should be accepted or denied. So what are the criteria to accept any connection? So we have the five tuple values which the firewall will use to build a session. But on top of that, firewall has some parameters. So to start with, the first parameter will be incoming interface, or let me put it in the firewall term, to the way which we configure in policy. We have our source interface, then we have our destination interface, then we have our source address, we have our destination. Destination address, and within this source and source address, we can also refer the user or user group, and then we have our internet services. So internet service is different from our normal service. We will look into this. Then we have our schedule, and at last we have our services. So what's the difference between the internet service and the services here? So this services here refers to the port number. So the internet services here refers to the ISDB in our FortiGate firewall. So user and user group, we have another session for this. When we discuss authentication, we will discuss more about this. And among this eight service, two of them are optional. So which of the two are optional? So the user identity or user and group, this is optional, and then the internet service is optional. But if you take a normal policy, you will always find these four plus these two, these six configuration always there. So these are the must-have configuration for your policy to work. And schedule, when it comes to schedule, by default, there will be a schedule which says always. That's the default setting. But if we want, we can customize it so the policy will stay active on a specific days or a specific time period. Now, what will we do after configuring with all these parameters? So we will either accept or deny. There are only two options in the policy. So we will either accept the connection or we will deny the connection. So when we accept the connection, a session will be built and the traffic will be allowed. And when we deny the connection, there won't be a session built on the firewall. The traffic will directly go for a denied. So it's not that even if you configure a policy to if there is no policy to allow the connection, the session will automatically denied and because we have an implicit deny policy at the end. And the policy matching will always happen from the top-down approach. So we have to place the more specific policy on top and the wider policy at the bottom. Other than this accept and deny, there is another option, there is another action which is called IPsec. Some of you might have come across this on the policy. You have an action which is called IPsec. Now, this action is what we call as policy-based VPN. So, if you're familiar with Cisco terms, they have two type of VPN. One is policy-based, and another one is route-based. So by default, FortiGate will work as a route-based VPN, but you can also modify it to behave as a policy-based VPN. So when the firewall is configured for policy-based VPN, you have a firewall policy with action which says IPsec. So only if the traffic matches to this policy which you configure, the traffic will be sent to your IPsec channel. This is the short description for policy-based VPN. Now, what we discussed so far, this is the common, these are the common things for policy. Okay, let me put it this way. So in FortiGate firewall, we have policy based and we have profile based policies. So these are the two ways to create a security policy. So whatever things we have discussed till now, this is common for both policy based and profile based. So what is the difference between the policy and profile? So the idea is simple. So if you are configuring a policy based security policy, which is our traditional policy, sorry, profile is the traditional one. S- So let's say we are configuring a profile-based security policy. So in profile-based, you will be matching your traffic on source interface, destination interface, source IP, destination IP, and then services. Based on when with this matching criteria, you will say either allow or deny. And once the policy is allow, if the action on the policy is allow, then this traffic will be given for UTM inspection, where you will have all your security profiles. So when we say security profiles, we have antivirus, IPS, application identification, and then our web filters. So based on our action here, allow or deny, if it's allowed, then we will proceed with the UTM inspection. This is the normal security policy configuration, which is enabled by default in our FortiGate firewall. Now, what is the profile based? Sorry, I'm so sorry. I'm keeping on confusing between this. Now, what is the policy based VPN? Now, this policy based VPN is something which we have to enabled specifically under VDOM setting. So you can either enable it for the either on the VDOM setting or under uh, config system config system global, which is the global setting for your firewall. You can say that you are going to define your policy security policy mode as policy. So when you say policy, you by when you say policy based, the difference is you will be able to call app ID or web filters directly in your security policy. So this is similar to Palo Alto firewall, where you can directly call an app ID function on your security policy. So if you enable policy-based firewall security policy, then you have the ability to configure app ID or web filters directly in your security policy along with your matching criteria. Optionally, you will also get the option to configure other UTM profiles if you enable this. So now, with this, in a profile-based policy, the NAT functionality is inbuilt on your security policy. But when it comes to policy-based, you have to configure a separate NAT policy. So NAT policy is something which you have to configure separately, and this is what we refer as central NAT. So I can give an example. So if in FortiGate firewall, whenever you configure a policy, you get an option to choose NAT, and most of the time, this NAT is based on your destination interface. Now, if let's say you have hundreds of policies, let's say you have like 100 policies, and in this 80 policy is for internet. Now, let's say you have two ISP links. Now, in these 80 policies, your destination interface is gonna be a same. It will always be this two ISP links. Now, even though this parameter is common on all 80 policies, you have to specify your NAT configuration, where you have to say either use the outgoing interface or use a pool depending on your ISP link. Now, with central NAT, you can write a common policy which says any connection coming from your inside network or your LAN network going towards your internet, you do the NATing and you configure the NAT parameters here. So now you don't have to configure NAT on all 80 policies. You're directly referring a single policy which is performing the NATing, and this is what's referred as central NAT. So this gives you some more granular control where you can say what type of traffic or what maybe a particular set of users can use a specific NAT pool and others will use a different NAT pool. So you get more granular controls in central NAT, but this is the basic idea. Now we will come back to the central NAT later. Now let's focus on our profile-based policy today. So let's go back to our GUI. Okay, so currently we are in our root VDOM, which is working as a normal profile-based policy mode. Okay, so let's create a policy, and the easiest way to identify profile and policy based is if you get all your UTM profiles here, security profiles, then you are in profile based mode. Now, let's say ISP, let's say this is an internet. So the first thing first, we need to provide a name for our security policy. So let's give a meaningful name, which is easy for us to understand. And then comes the standard or ZTNA. Now, a ZTNA is another config which we might discuss later, but not now. So let's go with the standard policy. So the parameters are your incoming interface and outgoing interface. So in incoming interface, we have our LAN network. We can choose our LAN networks. So port 1. And in our outgoing interface, we can say port 2. Let me confirm this in the lab topology. Okay, port 2 is going towards our internet and port 1 is in our LAN segment for this firewall. Okay, 5, 6. Now, this interface is very common. So whatever interface you have in the firewall, you will be able to use that. Now, optionally, let's say while creating policy, let's say you want to create a new VLAN interface. So you can directly do that from here. Just click on the add and then configure a VLAN interface or other VLAN interface type, and then refer it in your policy. In source, we get the option to either specify an address. So let's say all for the time being. And in the destination, again, let's say all. Or in the destination, you get the option to call your internet services. This is the ISDB which we have in our firewall. Let's say if I want to allow connections only to Microsoft. So I can call upon that specific ISDB and then I will allow that. For example, Microsoft updates. So let's say you need to configure a policy which is going to take care of your Microsoft updates. Okay, destination all should be removed. Okay, which is going to allow your Microsoft updates. Now, in the schedule, you can define a schedule which says, I want this policy to be active or reoccurring schedule. I can say only on weekends. So only on weekends, I want this policy to be active, and that is between, let's say, 6 p.m. or let's say all day on Saturdays and Sundays. Only between this time, the policy will be active. Now, what's the advantage we get because of this? Let's say on a production setup, you don't want to on a production setup, you don't want your updates traffics to come in choking your network. So let maybe your AD or your all the systems in your network are configured to check for updates only on weekend, and only at that time you want this policy to be active. So if you configure it this way, the firewall will stay disabled, and only during the schedule the policy will become active. And there is a cron job running in the firewall. That cron job will take care of this schedule, whether to activate or disable a policy. And then comes our action, accept or deny, and flow and proxy based. So in the last class, we discussed what is the how the traffic will be handled between flow based and proxy based. I hope that is clear for everyone. If you have any questions, we can discuss this towards the end of today's session. Now, these are the basic parameters which we need to configure to match our traffic. And this destination is something, a destination interface or outgoing interface is something which we should know based on our routing. The if let's say if your routing is pointing your traffic to port 3 and if you configure port 2 as your outgoing interface, then your traffic will not match. So for the interface, for the policy to match, need to make sure that these five parameters are configured correctly, because based on these five parameters, a policy match will happen. I will show you how a policy match will happen once we complete this. So be careful when we configure these five parameters. And then comes the NAT part. For the time being, let's leave it with the outgoing interface. So whatever outgoing interface we have, that is port 2, and whatever IP address we have on that interface, that IP address will be used to perform a source NAT translation. So this is a simple source NAT translation which uses the outgoing interface. Okay, and this is the port address translation which uh, which is being done here by default. And if you want to preserve your source port, you can use this so that your whatever source port you are receiving from your client will be preserved when the traffic is being sent out. Now, this can create issues if you have a very huge number of users, but very limited IP pool. So this will create source IP address clash. So it's best to avoid this. Only if it's necessary, enable this option. And then we have the protocol options, which defines which protocol communicates on which port number. Now, this protocol option is used for protocol decoders. Now, if you remember the last class where we discussed about life of the packet, we have something called protocol decoders in one of the stages. So, based on the protocol decoders, IPS will function. So IPS is if it wants to inspect the traffic, it needs to use the protocol decoder to do the regular expression matching. So for this function, if you have an application which, let's say, you have your custom application coming in on HTTP using HTTP protocol, but you having it on different port number 8080, then you have to specify it in your protocol decoder. Only then the firewall will be able to process it for UTM inspection. Which means if your let's say you call your service. One moment. Okay, let's remove this Microsoft update and let's say destination all. And now you get the option to service. Let's say you refer your HTTP service here, which refers to your normal port 80 traffic. Any traffic coming from TCP on port 80. Now this is going to now with this configuration, your policy will match only for the port 80. Now let's say I just allowed everything here. I say all services are allowed. And still now my traffic coming on port 8080 will be matched against this policy. But if my protocol decoder is set to port 80 instead of 8080, then my IPS won't be able to decode this traffic for the UTM inspection. So these are some of the minor things which we need to take care when configuring a policy. Let me rephrase this or explain it once again. So let's say we have a policy which says all services allowed. So which now even if I have a traffic coming on HTTP port 8080, this will be used along with the source IP, destination IP, source interface, and destination interface. Along with this, service will be used. These five parameters will be used to match a policy. So my policy will be matched. But let's say if the policy is allow, and now it has to go to UTM inspection. Now at this stage, we need a policy protocol decoders. Protocol decoders. And if the protocol decoder is configured for HTTP 80, but your actual traffic is coming in on 8080, then your decoder will fail and UTM inspection will not function properly. So we need to be very careful. What if you are customizing the service, then please make sure you customize the protocol decoder also. So If we are using default, then all is good. By default, we have all these protocols running on default default port numbers. And then comes our UTM profiles. Now we have another session where we will discuss all these UTM profiles in detail. But for today's session, let's keep this to the basic security policy. Now, one after security policy, we have an option to how to which defines how to log the traffic. So we can either log all session or security events. Now, when we select security events, it will only log any violations on this UTM events. If we select all session, everything will be logged. And if you enable this generate log a session start, you will have two sets of log in your policy in your logs on the firewall. So by default, um, the default log action is log a session end. So in terms of logging, uh, only after a session end, the traffic will be logged. Now, let's say you have a long-lived session which is running for like 50 days, and it has like maybe like 500 GB of data being transferred by this session. This is a long-lived session, and this session is active and it's transferring like 500 GB. Now you will not see this particular log, or you will not see any logs for this particular session in your forward traffic log. Now, but if you check your utilization on the graph on the firewall, you have a graph to check the utilization, which will show that you have like 500 GB of traffic being transferred, but you won't see the traffic being logged in your firewall. So if you end up in this kind of situation, then you can enable this option which says log at session start. Please pardon my handwriting. So you can enable this option logger session starts. So even for the same um, long live session, now there will be two logs generated. One log when the actual traffic started, that is on day one, and then the second log on day 50. So you won't be left in the blank. You have at least some logs to check when you check your traffic logs. So this will be useful in this kind of scenario where you are expecting some long-lived session. And then you can add some comments and then enable the policy. Now, another thing which I wanted to show is users. So eh, by default, you will select your addresses in your policy, correct? On your in the source, you will always select your address, but you can also select your users. So which means if you have any users or user group available in the firewall, that user can also be directly referred in the policy. Now, when you refer the user, now this user can come from any IP address. So you're not specifically binding the user to a single IP. But this user information is not something which firewall can use to match a traffic. This can be used for secondary authentication on the firewall, but let's say when you receive a traffic on one of the firewall interface, a TCP packet or an IP packet that doesn't have the user information in it. So without the IP address, firewall won't be able to match it against a policy. For this purpose, we still have to specify an address. So it can be an all address or it can be a specific address which we need to mention. Now let's with this condition, let's say if the condition is placed in this way where I have an all as an address and then a guest user being selected. So any traffic, any source IP will be accepted, but after this stage, once this stage is completed, this policy matching is completed, or during the policy matching, Fiverr will go for a user lookup where it will check its local database or the authentication profiles to see do I have any user with the name of guest. Now, If there is no guest, then the firewall will prompt for an authentication. Now, if you specify any user or user group, firewall will directly provide, and if the user is not in its table, firewall will directly provide an authentication page. Let me explain it this way. Let's say we have a firewall, and on port 2, I'm receiving an IP packet which has the source IP address, let's say 10.1.1.1, and the destination IP address 8.8.8.8. Now, let's say this is a HTTP traffic, for example. Now, in terms of policy, I have a policy which says source interface is port 2, destination interface, for example, let's say port 1, and in source IP address, let's say 10.1.1.1, destination IP 000, for example, and in source user, I have selected guest, or I have selected user 1, for example. Now, firewall, upon receiving this traffic using the incoming interface, outgoing interface, and then the protocol and services, it will try to match with the policy, and this particular policy will be matched. And the action accept or deny can be decided. But when it is checking this user source user field, it sees a username. So when it says a username or group, the file will directly check its database to see if it's a known user. Now, there are multiple ways for the firewall to learn this user. With this, we will discuss in another session. But once we get to know, once we check this user database, and if it's a known user, we are all good. We will match it against the policy, and then we will accept or deny. But let's say we don't have any entry in our user database. There is no entry. Now, in this case, what the firewall will do is firewall will stop processing the policy, and on the same interface, a redirect page will be sent for user authentication. Now, this redirect page will be on HTTP, and this will be your captive portal authentication. So the user will get a web page which gives them the option to enter username and password, and then the username password will be again checked against our configuration. And if the config user is allowed, then a database entry is made. So now we have a database entry for this user one or guest, and this can be used to match against the policy. So if there is no username specified in the policy, then we are only doing the basic check. We are not checking against the user. So we don't have to check the user database. Simply we can check against our whatever information we receive in our IP packet. We can compare it and we can allow this policy. Now we are leaving this security profiles part now. We will come back to this. Now let's discuss the policy based. Now for policy based in lab, let me switch to the next video, that is policy central NAT. The moment you enable policy based security policy or VDOM, uh, two things happen by default. One is your central NAT. This feature gets enabled, where you have to create a central NAT, and then you get this SSL inspection and authentication profile. Now, in this SSL inspection and authentication profile, there is a default profile which is enabled by default, which is for all source from going towards all destination. And the reason why we see two all is one is for IPv4 and another is for IPv6. So we have all source going towards all destination with all services allowed, and it does a security certificate inspection. Now, again, we will focus more on the certificate inspection when we discuss our UTM profiles, but for the time being, just keep in mind, it only does a certificate inspection. It won't do deep inspection. And then we have a NAT, which is custom. Now, this NAT part is something which we have to enable. Now, let's say I want to do a deep inspection. I can simply create a matching criteria with incoming interface, outgoing interface, and the source and destination IP address. Then I can select my inspection level as deep inspection. Now, in our profile based or in the other way, uh, all these functionality, this security SSL inspection and your central NAT or your NAT configuration, these are combined in your policy. Let me show it here once. So switching back to root. If you see here in a normal policy based mode, your NAT functionality and your SSL inspection is combined directly in our policy. But when it comes to uh, policy based, we are separating it. The reason why we are separating is these settings are going to be common for all the traffic. So you don't want to end up creating this in all hundreds or thousands of policies. So you create your common SSL inspection profile. If you want to do deep inspection, fine, we will do deep inspection straight away here. And if you want to do NAT, good, we will do NAT straight away here. In terms of NAT, it's the same. We are just matching the traffic against the source interface, outgoing interface, source address and destination address. And then we do the NAT criteria. So I will come back to this NAT criteria. Now let's check what is the difference in our policy. So let's try to create a policy here. You will see some difference. The first difference is you won't see the NAT option here. And the next thing is you won't see your SSL inspection profile here. Rest all the things are same, and the major difference is your application and URL category. So this is something which you can refer directly in your policy. But if you check the other mode, let me show you that. Now, if you compare it with the other mode, you won't get. Okay, let me switch back the video. Sorry. Now, if we compare it side by side, uh, you won't get the you won't get to choose the application and URL on here. So you application and URL is always handled by your security profiles, but in your policy based security policy configuration, like here you can directly specify the application URL category. And another thing, if you notice, is there is no option to choose flow based or proxy based mode here. So how do we control the flow based and proxy mode? So let's go back to global. I should see an option here. Okay, we'll come back to that. So what I was saying is that we don't have an option to select either a flow based or proxy based, what type of inspection we do here. Now, the main if a customer is deploying these kind of setup in a policy based mode, most cases, they will go for a deep inspection. So there will be an SSL inspection which says the traffic has to be decrypted, because only if you decrypt the traffic, you will be able to match your traffic against an application or URL category. Because application and URL category are two fields which can only be identified if you decrypt your traffic, because these are layer 7 inspection. So in most cases, only if you go for deep inspection on all your traffic, then you will be moving towards this kind of policy-based security policy. But not every customers will do it. That is why you see the default mode as profile-based in FortiGate firewall. Now the rest all UTM profile is the same. There is not much difference. It's the same as your normal policy configuration. Okay, there is one more thing which I wanted to show you. So let's say you have multiple LAN segments, or let's say you have like 5 interfaces coming from LAN, and you're going to allow all of them to your internet. Maybe five of physically it's 5 different ports coming from 5 different switches or distribution switches or access layer switch. But end of the day, you want to allow all of them to your uh, internet connection. But in security policy, you only have the option to select one interface at a time. It doesn't allow you to select multiple interface. So you don't want to end up creating 5 different policies which can be configured in the same. What I'm saying is, let's say you have a firewall and then it's connected to maybe 3 different access switch. Now, maybe this goes to HR, this goes to finance, this is production or whatever. Now, we want to provide internet connection to all these 3 interfaces, but policy will allow you to select only one interface at a time. Now, let's say this is a common policy, so any user can access internet. So maybe this is a configuration. Now you don't want to create 3 different policies with the same matching criteria, because it's going to be the same. Anything coming on this interface, allow it to this interface and do a natting on this interface. It's the parameters going to be the same for all these 3. So you don't want to don't want to have 3 duplicate entries, because if the number of policy grows, then the policy matching or the initial slow path matching will take time. So let's say you have like 5,000 policies, and if you receive a single packet on your firewall with source IP, destination IP, and all the fields, now when you build your initial session, all packets has to be matched against this 5,000 policy. This is for the slow path where you build a session. Now, if the more number of policy you have, the slower this will become. So it's always important to have this policy streamlined. It's not that firewall cannot handle huge number of policy. If you check the table size for your any particular model, you will be having like more than 1,000 policies which you can configure. But we are not going to do that in a practical setup. So to avoid this duplicate entries, what we can do is under your feature visibility, you have an option called multi-interface policy. Let's check that. You see here multiple interface policy. Now, let's say once I enable this option, now I have get to choose multiple interface in my security policy. So let's say in the incoming interface, I choose port 1, I choose port 2, I choose port 4. No, all of them will come in my incoming interface. So now this way you're reducing the number of policies, and by reducing the number of policies, you're reducing the time taken for the slow path or the initial session building process. Now, if you don't let, there can be situation you can maybe you choose any interface or as the source, and then you can choose maybe a specific interface or your ISP links. It depends. You get these options once you enable that feature. And one more thing I wanted to show you. Let's enable this all. Okay, so in terms of view, we have like two views. One is interface pair view. So if you remember, we selected only one we created only one policy, but here it shows us two different policies. So all we created was one policy, but we see two different policies here. So why is this? So let's enable one more option. So let's enable this ID field and let's check this. Let's bring it to the front. So if you notice here, the ID is something that is common for both the policies. And even I created only one policy, but when it lists in the GUI, it lists it as two different policy. This is because we have selected the view as interface pair view. So it says any traffic going towards port 2, this is the policy. For any traffic going towards port 4, this is the policy. So basically, Firewall will group your policies. Let's say I create one more here. So traffic coming from any and port 4, sorry, any test 2, and then let's say the outgoing interface is port 4. Let's say all, and services all. So basically, firewall groups your policies in this interface pair view. So this can be helpful in certain situation, or if you're troubleshooting, like like this you have like very huge policy base where you have like thousands of policies, and for sure like a traffic you're inspecting or troubleshooting is coming from a specific interface. So you don't have to go through all the other policies or scroll down the list. You just focus on which interface the policy is going towards, and then you will get all the view. So now, maybe the policy matching is not functioning between these two policies. So you can only focus on these two. Now, this can get confusing if I go by sequence. If I go by sequence, now you don't know like which policy is going to match. So in these situations, your view will help you for troubleshooting, but just keep that in mind. But anyways, the ID, let me enable the ID once again. The ID is the important thing here. The ID is assigned based on the order which you create your policy. The ID is assigned based on the order, but that doesn't mean like this ID is what used for policy matching. I can move the ID to the top, But still, when it comes to traffic matching, traffic will match this policy ID 2 first because that is on the top. The order in which you arrange is what matters. Now, in firewall, how do we check one? Let's say we have arranged all our policies here. IDs, we have 1 and 2, and maybe if this number is confusing, how do we check which policy is on top and which policy is on bottom? So show firewall policy. So you can check from the CLI and you can check the order which one is on the top. And the next thing is diagnose firewall iprop list. And iprop list is the kernel database, but I want to focus on specific. So just the command which I entered is diagnose firewall iprof list 1 and then 4 zeros followed by 4. So this is a group. This number is just a group reference, and it refers to the firewall policy. So basically, this is how a policy will look like in your kernel entry. So when the FortiOS code tries to match your traffic, this is what it chooses. Now again, if you see here, we created 2 policies, but we see 3 policies here, 3 entries here. So entry number 1, entry 2, and then we have our entry 3. So this third entry, which is having the policy index 0, this is our implicit deny policy. So this will always be there, and even if you check in your log, if you see policy ID 0, but if you come to your GUI, policy ID 0 is your implicit deny. And then in terms of matching, this is what it looks like. We have a policy index, and based on this policy index doesn't matter. Let me rearrange the policy. So let me bring it down. Now setting has been saved. Now, if you see here, the kernel has been updated. Policy index 2 has come to the bottom. Policy index 1 is on the top. So what I meant to say is the ID number is just for identification. So don't go with this ID number to say like this is the least number, so this will match first. That is not true. Only the order is what matters here. So based on what order you have placed your policy matching will happen. And you can verify the order either from the CLI configuration or by verifying this iprop list, which has all your policies. Now, when we go for a debug, we will check what are these fields, how to interpret this information. We will check this in another class where we learn how to take debugs on the firewall. Okay, and one more thing, show firewall policy. You have this UUID. So this is something which you haven't configured, but the firewall will assign this number. And this is the purpose of this number, this unique identifier, is only to go through the logs. So in FortiGate firewall, logs are stored in SQL database. So when firewall goes through the logs, this UUID will be used to fetch the logs easily. So you have the option, just right click and it says show matching logs. When you do this, basically it uses the UUID to search the logs. So that is the purpose of this UUID, and this is unique number which we cannot change. This number has no effect in your configuration. It's only for the log purpose. So please ignore this in configuration. Okay. So now we Now let's create a policy and let's take a look at it like how it will work, how the logs can be checked. So these are dummy policies, so let's leave them as it is. So in our lab, we have traffic coming from port 1 going towards port 2. So let me create a policy for that. So lab internet access, incoming interface is port 1, outgoing interface is port 2. And in source, let's create an address here. So let's say uh, LAN, sorry, PC1, and we can say we know for sure this traffic is going to come from port 1. So let's say port 1, but this is not mandatory. You can keep it as any also. By default, it's any. And then the type as subnet, IP range, FQDN, or geography, or whichever we want to choose. So if I choose subnet, I can specify an IP address. So this is a simple configuration. Now, if I choose an IP range, again, I'm good. I can say 10.1 going towards 10.1.1.254. I can specify a range here. So these are the different ways I can create an objects in firewall. Then we also have the FQDN, which says, let's say fb.com, www.fb.com. Now, if I do this, firewall will resolve the DNS for this um, domain, and whatever DNS it resolves, that IP will be injected into your security policy. So when the firewall matches the destination IP address, it uses the domain name, it uses whatever IP address it resolved for the domain to be matching. So let's create this also. So let's create this object fb.com. We will test this in lab. Oh, this is wrong. Let me edit this. Um, One moment. So this PC is 192.168.1.254. I have another PC in 250. So let's use that. Okay, some misconfiguration. Let me directly go to the addresses and delete this PC1. I should be able to edit this type. It's not allowing me to edit the type. Okay, delete. Let's say PC1, I have an IP address 192.168.1.250. 1.250. This is a PC which I have in the lab. Okay, we will use this. And then also create one more FQDN, fb.com, and we will say here, this is an FQDN based object and w.fb.com. And we will also test this in our policy. And what other types we have is we have geography. So in geography, you can select your country. So let's say you want to allow VPN connections only from India, for example. So you can do this. So only the IP addresses in the range of India. Now, where does the firewall knows how the firewall knows what IP belongs to India? This is firewall will receive an update from FortiGuard, and FortiGuard will learn this from INA. So INA is an organization that assigns IP addresses. So it will learn the geography information from there. And then we have our dynamic, where you can have your you can have objects being learned from all these connectors. So for we can either use fabric connectors, ClearPass, or NAC. This is FortiNAC is another device from Fortinet. Then FortiPolicy tag, voice tag. Then FSSO is an authentication mechanism. So you can also learn from FSSO. Basically, this is a user group configuration. And then you also have device MAC where you can configure your MAC address directly in your policy. Now, I have seen mistakes in this MAC configuration. For example, let's say we have a firewall. In one interface, we have our PC directly connected, and in another interface, we have this going towards a L3 device, and then we have our PC. Now, let's say this is a distribution switch, not router, distribution switch, maybe acting as an L3 because distribution usually acts in L3. Now, if you enable your MAC-based objects, it will work here because firewall interface is directly learning this PC's MAC because they are in the same broadcast domain. But if you configure similar MAC-based policy here, it will not work because whatever traffic you initiate from the PC, when it crosses your distribution switch, your source MAC will change to this interface's MAC address. So if you have another PC, it will also have the same MAC. Another PC, you will have same MAC. So depending on your network setup, you can choose whether to go with MAC-based policies or not. If they are in the if the user and the firewall is in the same broadcast domain, then you can configure these kind of MAC-based objects, and then you can refer the MAC-based object in your firewall policy. So let's create LAN internet port 1 is my LAN, port 2 is my internet, and in source I will say PC1, and in destination I will say fp.com, and in services this is only for HTTPS, right? So HTTP, yes, because Facebook runs on HTTPS mostly, so let's do that. And then flow based, I'm not changing anything else. So NATing, I'm just using the outgoing interface, and policy is in flow based mode. And let's say all session and generate logger session start. Now, this is one policy which I can created, but since I have a specific destination here, this destination will not allow me to access DNS because for the LAN definitely I need DNS. So let me clone this policy. So I can copy this policy and then I can right click. I can paste above or below. Let's say I paste above, and in this edit, I can give it a name, uh, LAN DNS, and in this, I'm only going to allow DNS connection. So I don't have an object, so let's create an address object, which says DNS subnet 8.8.8.8. Okay, I would like to select DNS, selected. And in service, now this is DNS, so let's allow only DNS here. I'm not changing anything on the NAT. So for the NAT part, I'm keeping it as it is. And yeah. Okay. So by default, when you clone, the policy will not get enabled. They will be disabled. So, but we can enable it. Set status enable. Okay. So I have my policy for DNS. I have my policy for NAT. Now this is going to allow only fp.com. Now let me check that address. fp.com. It has not resolved to an IP address. So let me check the firewall's DNS configuration. Network. Okay, it's in the global. So let me go back to global. Okay, DNS is reachable. Okay, let's troubleshoot it on the way. Okay. So now as per my policy configuration in my root VDOM, what I have is I have a policy to allow connections coming from port 1 going towards port 2. And this is for DNS connection because service is again only DNS. And then I have an internet. I have another policy which is going to allow only fp.com. So let's check this. Now this PC1 250 192.168 1.250 in our topology, this is the PC. So let's open that. So this is the IP address 192.168 1.250 and 1.1 is the firewall interface IP address acting as gateway. Now let me configure the DNS here to 8.8. Okay, it's 8.8. Okay, fine. Close. Now, I am sending a ping, but this ping traffic is also working. But as per our policy configuration, this should not work. So let's see how it worked and which traffic allowed it. So let's go back to the firewall. And if you refresh the firewall policy, you have this option hit count or the bytes. We can also enable hit count. Let's enable that. So here we have something called hit count. Okay. So this can help you for investigation. So this one policy has taken 100 hits and it has allowed this much traffic. Now, what is this policy? Basically, it's any policy. It's allow any connection coming from any interface towards port 2. Since port 2 is our ISP connection, and it allows all services, all IP addresses, or traffic started matching with this. So this is where the order comes in. So even though I have a specific policy, since this policy is in the bottom, it's not taking hit. My intended policy is not taking hit, but my some other policy is taking hit. Now, if I check the logs, I can right click show matching logs. Memory. What's the log setting on that? Okay, my log setting on this policy is set to security events, so there is no UTM profiles. That's the reason why I'm not seeing any logs for this. So this doesn't mean something is wrong in the network or configuration. I don't see the logs, but traffic is working. So the scenario is I don't see the logs, but my traffic is working. So how the firewall is allowing this? Firewall is allowing this by this policy, but it's not generating logs because of this configuration which we have in place, which is security events. So I have seen customers complaining these kind of issues. Like I have a configuration in place, firewall is not behaving as it is expected to. It's allowing some random connections, but there is no logs in the firewall. It's always a human error, so we can change this to all session, and then we can check our traffic once again. So let's initiate the traffic. ICMP ping 123 stop. And my hit counts must have increased. Let's check. Earlier it was 100, now it is 106. Now let's check the logs. Right click, show matching logs. Priority search different. Why it's not generating logs? Did we make any other mistake? Let me check. Okay, let's do log session start as well. Log and report forward traffic. It's the log setting which we have. So, okay. Okay, so local traffic logging. Okay, only for local out traffic. Fine. Event logs, all. Then local logs, memory, thread weight. All the settings are good. We should see some traffic logs here, but we are not. Okay, let's rearrange this and check the others. So let me bring the DNS and LAN internet to the top. So now with this setup, now with this setting, ideally my ICMP should not work. Still it's working. So which hit it took? Okay, so the reason why it worked is first two policies didn't match. The third policy matched and it started working. So let me disable this third and fourth. Set status disable. Okay, now with this configuration, it should hit the implicit deny. My ICMP should hit implicit deny. Okay, so now my ICMP is hitting implicit deny. Now for implicit deny, again, by default, the policy is not logged. So we have to enable this log IPv4 violation traffic. Only then a log will be generated for this. Now our ping is not working. We good. Now it should generate some log. Let's see if logs are there. Okay. It took some time. See, earlier it was working, but it took some time to provide the logs. So this is the one matching the test one. So the test one, now you see two entries here. So you see here, this is the log when it says log start, and this is the log which is generated when the log ended. So let's check what's in this. So in log start, you will see the receive byte and send byte as 0 because it just says there's a traffic flowing. But if you check the log at session end, it will show you that there is a traffic flow, how much amount of traffic it has flown, and what is the action it has taken. So the action is okay, where is the action? Action is accept. I think we won't see the action here. Okay, the action is start. So this is the difference which we need to keep in mind when we check the logs for this log of session start and session end. Then deny traffic, this is hitting implicit deny, so we will see the policy ID as 0 and no traffic allowed. Policy ID. Where is the policy ID field? Um, One moment. Okay, policy ID is enabled. Okay, here it is. Okay, it directly said implicit deny. But if you see here, we get the policy ID 1. Now, I within a bracket, we see the policy ID and then the policy name. Now let's check some other traffic. Now we have DNS. So let's generate some DNS traffic. So NS lookup, let's say google.com. So this will create some DNS traffic on the firewall, correct? So let's check. Now, if you see here, LAN DNS. So this is the policy which we created to allow only DNS connection. So we got a DNS request coming on protocol 17 service DNS, that is port 53. So session started, and in the next log which says start deny. Okay, where it is? Okay, the session has not ended. That is the reason why we only see start here. UDP sessions will stay active for 30 seconds, I believe. So let's wait. Oh, 1.254. This is another PC. If you remember, my this Windows PC is 150. The IP address is 1.250. But there is another PC 1.254 which is trying to connect DNS. So it's getting denied by the firewall. One moment, guys. So the reason why this 1.254 is denied is because we don't have a policy to allow this. Our security policy allows only 1.254. Now I hope the session must have ended for the DNS. So let's check that session log. So this let me clear this clutter. So I can do this filter uh, does not overlaps 1.254. So this should be removed. So if you see the condition here, 1.254, it's removed. So it will not show logs for that anymore. So I only see the session started. I don't see the session ended for DNS. So let's check that session table on the firewall. Um Diagnose firewall session. I don't remember the command on top of my head. One moment. Diagnose firewall session list. One moment, guys. Let me check what's the command for session. Okay. It's diagnose system session list. There's a good chance session must have ended. No. Oh, we still see this protocol 17 sessions here. If you see, oh, the expiry is more than 1500 second. Duration is more than 1500. Expiry 32. Okay, in 12 seconds, this session will get expired. And this is a session which is coming from, uh, this is different, 172. Okay, here it is, 192.168, 1.254. Okay, now you're looking for 1.250. So I can session filter. I can set the source 192.168, 1.250. Then I can list my session. So there is zero session matching this. This means the session must have ended. So we will see the log. Okay, there it is. So if the session is active in our session table, or if the session has not closed, then we will not see this log. We will see these traffic logs only when the session closes. Now, this is something which is very important when we have long-lived sessions. If the session is going to stay on the firewall for longer time, then we won't see the traffic logs. So now how to verify the session in our CLI? So we have this command diagnose system session list, which will basically dump all the session. But before doing this, we can also set a filter. So in filter, we get a lot of options. We can match maybe all the sessions for a policy ID or for a source interface or for a source IP or destination IP. So this is for source IP. So we can set the filter, and once the filter is set, then we can list and it will list the session. Now, when we clear the session, let's say I want to clear. If I do clear the access session clear, this will clear all the sessions in the firewall. So we need to be very careful when we clear the session. We need to be very careful when we clear the session in a production firewall, because there are two options to clear. One is to clear the session and another is to clear the filter. So if you say session filter and then you clear, this will clear whatever filter I have set earlier. So to show the filter, you can run the command diagnose system session filter. This will show what is the filter you have set in place, and then you do clear. It will clear my filter. If you see here, if you can compare, earlier I had source IP address set. Now I don't have any filters. Everything is set to any. But instead, if you say directly clear, you will lose access to your firewall temporarily, and your all the sessions in your firewall will be removed. So this is a very dangerous command to be used in production setup. So please be very careful with this. Okay, the time is wrong. So Nagaraj has a question on chat. The timing is wrong. This is because the time on the firewall is currently, what's the time we have? Oh, get system status is in global. Oh, it doesn't show time here. No worries. The system time is currently 9:37, so it is wrong. So that's the reason why we see logs from different timestamp here. Okay, now let's go back to the Facebook. Now this DNS part is clear, and how the session, how the logs are being generated on the firewall with respect to the session is clear for everyone, I believe. Now let's, from the PC, from the user PC, let's try to access fb.com and let's see how that behaves. What is this? Oh, got it. Okay, so fb.com. So I have a policy to allow this connection. So let's see if the firewall allows this. It's loading. So connection didn't go through. So the connection got timed out. So let's check the firewall logs to see what happened. Because we have a firewall policy which is supposed to allow connection for facebook.com. So let's see what went wrong. So first thing, let's verify if this policy has taken a hit. So it has taken hits. So 4 hits we have. So this is good. Now let's check the logs. What happened with this? Show matching logs. So if you see here, LAN, this policy LAN internet, this is what we have configured. It has allowed the connection for fb.com for this IP address 157.240.192.35. Now let's do a NS lookup from this PC, fb.com. Let's see what IP we resolved to. 157.240.192.35. So it's the same IP address. So from the firewall perspective, this connection is allowed. When I say allowed, I can see 15 packets on the being sent, 14 packets being received, and it's HTTPS connection. Connection has been closed. But still, on the user PC, we see error connection timed out. We don't see Facebook working. The reason why it is not working is your connection to the site is not secure. Okay, learn more. Sometimes this Chrome will do this. We don't have security deep inspection set yet. The policy which we set is for certificate inspection, correct? Oh, there is no inspection. So firewall is not doing any inspection on it. Still, our connection towards facebook.com is not working. So what could be the reason? So now currently the filter is set to this particular policy. Let's remove this and let's see what's happening. So lot of denies. So Google Store, translate Google API. Let me remove this 254 clutter. This is not our IP address to investigate. Okay, so if you see here, there's a traffic going towards facebook.com, which is being denied by implicit policy. The reason why this is happening is because in configuration, in our firewall policy, the configuration which we have is to allow only fb.com, not facebook.com. So fb.com and facebook.com being two different domains, this particular policy is not allowing this connection. Now let's do one thing. Let's modify this policy. Instead of fb.com as destination, let's call an ISDB. So internet service, and let's see if we have an ISDB for Facebook. Oh, there is no ISDB for Facebook. Nice. Anything else we can test with? Okay, we have LinkedIn. Again, LinkedIn, okay, LinkedIn web. So let's check with LinkedIn web. Okay. Now in the destination, I have instead of an address object with the FQDN, I'm using an ISDB which has literally thousands of IP address. So it has like 34,000 IP address in this. So this 34,000 IP address, I can even view the entries. So how this is being learned, FortiGuard will give this update to the firewall, and how FortiGuard will learn this IP address. Basically, firewall Fortinet, they have this web crawlers. So these web crawlers will go through the internet, learn all the IP address, and report back to FortiGuard. And at the same time, for LinkedIn themselves, they will also publish what is their public IP pool, like on which IPs they are hosting their services. So all these open source informations will be learned and they will be compiled and sent to the firewall. So firewall will use that. Now let's apply this. Now let's test LinkedIn.com. Now I am getting the home page and this traffic must be allowed by that policy where we referred ISDB. So we will check that. So it's loading. So let it load. And if we check now, we see it's taking hit. Let's check all the policies, show matching logs. So you see the application name is LinkedIn Web, which is being matched with our ISDB, and this ISDB IP address will be part of that LinkedIn web. So you see the running service, and this IP address 13.107 is not only part of LinkedIn web, the same entry is part of LinkedIn DNS, LinkedIn SSH, NTP, LDAP, and RTMP. So even if I allow LinkedIn DNS, my connection towards 13.107 will still be allowed because this destination IP address is part of these objects. Excuse me. Now let's also check how to uh, verify that ISDB list entries. And then I will come back to this reason why we didn't load this page properly. So, for example, now we have this traffic log on the firewall, and now by clicking at this, we are seeing like this IP address 13.107 is part of all these services. Now, let's say I have an IP address, but I don't know which ISDB it belongs to or where the entry is. So, how I can check that? Obviously, from GUI, we have an option. Let me check. Uh, Application control. Okay. Under policies and object, we have ISDB, and I can do a lookup. I'm not sure if this will work. 182.5. No, it's only match the name. Okay, I have this option IP address lookup, and I can say let's take an IP address. 142.250, 138, 183.238. Let's use this IP address for lookup. 142.250.183.238 and enter. Now, if I do a lookup on the firewall, I see this particular IP address is being part of Google Gmail, Google Web, Google ICMP, Google DNS, a lot of other services. So this is one way to find. Now, if you allow any one of this, even if you allow Google ICMP, your connection towards 142.250 is allowed. But for example, let's come here. Why this page is not loading properly? The reason is because for the LinkedIn to function properly, let me show it. Uh, Inspect elements. Okay, inspect network. Let me reload this page. For this web page to be presented properly, there are a lot of other domains that has to be allowed, or it's getting the elements from maybe some different sites. For example, Google Ads or Google some JSS, something from Google is dependent on this website, or this website is dependent on some other websites to load properly. So let's wait for this to time out, and then we will see all those failures being listed here. So now if you see here, all these scripts failed, and that is the reason why this page is not loading properly. Now let me enable the domain here. And if you see here, the domain is not LinkedIn. We only allowed LinkedIn, but this is static.licdn.com. So because of this reason, now the website is not loading. From the firewall policy perspective, we have allowed the connection. From the firewall policy perspective, we have allowed the connection to linkedin.com, but still the website is not functioning. The reason is because I have an ISDB. I have a strict policy which is only allowing connection to ISDB, linkedin.com, or only allowing connection to IP address that belongs to LinkedIn. But for the LinkedIn website to function, I need to allow static.licdn.com. So let's see what is this static.licdn. So see, this is an Akamai server. So now let's take a look up on this on the firewall ISDB database. So on the firewall ISDB, let's check where this comes to. 183.82.248.10. So see, this belongs to Akamai. Now in the same policy, let me go back to the policy. Now in the same policy, let's allow Akamai. Edit. So we have Akamai CDN. So let's enable this. Now before applying this, I wanted to show one more thing. So let's go back to log and report over traffic. Coming from 250. So if you directly check the now instead of checking the console on the PC, the browser console, if you directly start checking the FortiGate firewall, you will see a lot of other domains, but you don't know which domain, why traffic is being generated here, or you don't know what's the purpose of all this traffic. Google APIs, we don't know why, who generated, or I don't know where this traffic is coming from, because it's not being listed in the domain. I don't know, maybe this PC, especially this Chrome browser on the backend, it's trying to connect to somewhere. So that is the reason why we see all these connections being blocked. So to make this website functional, to see what are the domains being blocked, we will go to the browser console, we will see what connection failed, and then we will try to match this in our firewall logs. So see static .licdn.com. This is being denied. So the reason it's Akamai CDN, which is not being allowed in the policy, and it's hitting our implicit deny. I'm just showing the ways how we can troubleshoot when we hit an issue. So now this policy has Akamai CDN enabled. Now let's reload this page. Now this page is functioning. Now I have an interesting question. You see, there are a lot of other domains other than this static.lis CDN. Let's short this. We have this domains LinkedIn, then trkn.us, then static LACDN. See, still some of them are failing, but these are for tracking purpose. So again, this is coming from a different domain, ponf.linkedin.com. So firewall is not allowing this domain. That is the reason why it's getting blocked. But this, even though firewall blocks this domain, it's not affecting the functionality of your website. Now, for example, you can end up in a situation, maybe this is a PNG, right? This people is a PNG. Uh, inspect. So this w3.org SPC. So some element, maybe let's say this logo is not being visible. Maybe this logo is not getting loaded in the website. So if you encounter such issues, so you can always check this domain, find out which element belongs to this logo, and see what domain it goes to, and see if that is being blocked by the firewall. Now, to verify whether it's being blocked by the firewall, you can rely on your forward traffic log. You see if any of them are being denied. Now, for this traffic, now this LinkedIn CDN has been allowed. LinkedIn and Akamai CDN has been allowed. So it's functioning properly. So let's check the traffic logs. And we still see a lot of other connections. See some connections going towards Adobe. In a way, they are coming from LinkedIn. We can understand it from the domain LNKD. But since we have not allowed it in the policy, they have been denied, and but it's not affecting the browser functionality. Now, this safe browsing HTTP gateway, this is something being generated by our Chrome browser. Now, if you get some time, uh, maybe we can play with this in lab today, and you can find out uh, which websites or well-known websites, how do they track the users? For example, this tracking.png. So if I allow this tracking.png, okay, let's do this. So this is just for experimentation. ponf.linkedin.com. Okay, it goes to LinkedIn. Oh, I will not. Okay, we don't know the IP address, but I wanted to show you. I want to show you something. So this is actually a pixel. So basically, this is a way nowadays websites uses to track us. So they will place if I allow all connection, maybe I can do it this way. Guys, this is only for knowledge sharing. So let's say I enable this policy, which is allowing every connection, right? Fail to save. So status enable. Why are you not getting enabled? Access denied. Timeout. Okay, so now this is change. This is allowed. Now let's load this, or I can go from here, open a new tab. In some websites, we will be able to see actually what element this is. Maybe I can try this. So basically, there will be a single pixel. So this can be placed anywhere in the website, and these will be used to track a user when they visit, how they interact. So this is a way. And if you play across this, maybe in some websites, you will also find something that will fetch your IP address. So it will report back what IP address you are coming from. It will basically it is it some of these elements will report back the metadata of your system, what configuration you have, what browser you are using, what's the CPU you have. So basically, that's how users are being tracked when they visit a website. If you get a chance, please do play around and see how the firewall policy behaves and how what are the access you need to allow for any websites to function properly or to allow all this connection. Now, in another day, we will again perform a similar operation. At that day, we will play with the UTM. Today, we were only playing with the security policy. Now, my plan today was to also discuss NAT, but we were running out of time. So we didn't discuss NAT today, and we didn't discuss central NAT. So in tomorrow's session, we will discuss, we will configure central NAT, and then we will also, um, what I say, we will also discuss how NAT will function in FortiGate firewall.